Hi, I'm Dimitris Charalambidis, and in this presentation we'll talk about factorizing quadratics using the table method. Given the quadratic expression ax squared plus bx plus c, we will now see through worked examples how to factorize it by using the table method. This table method is also known as applying the Vieta rules. Let's move directly to the examples. Example 1. Factorize 2x squared plus 5x plus 2. We will begin by finding the values of s and p. Remember that p stands for product and is always equal to the expression's constant term. Here p is equal to 2. On the other hand, s stands for sum and is always equal to the coefficient of x. In our case, s equals 5. Next, we move on the second step, which is creating the table. We start by drawing two lines that intersect, one horizontal and one vertical, and as you can clearly see in front of you, on the top right corner is where we write the product. Here is where we would write number 2. Then, above the vertical line is where we put the sum, which is number 5 in our case, alongside with an x. On the left column, we write the term containing the square as a product of two terms. Here, the term containing the square in the initial expression was 2x squared. So we have to write 2x squared as a product of two terms. Each one of these terms must contain the variable x. So the only solution of writing 2x squared as a product of two terms which both contain x would be to write it as 2x times x. That's why we put 2x and x on the left column. On the right column, it's the space where we write all the combinations of two numbers whose product can give us p. In our case, we write all the combinations of two numbers whose product equals number 2. Now, for each combination of numbers we already put in the table, which, as we mentioned before, already these numbers satisfy the product conditions, that is, that all of them, after multiplied, they give us number 2, we must check for each pair if they also satisfy the sum condition. So, we start by checking. The first pair was numbers 1 and 2. Indeed, 1 times 2 is equal to 2. But if we multiply 1 by 2x and 2 by x, the total sum would be 4x and not 5x. So we cross out this pair. We move on the second pair, numbers 2 and 1. Again, if we multiply 2 by 1, we would get 2. So the product condition is satisfied. Now, we should check about the adding condition. If we multiply 2 by 2x and add to that 1 times x, we would indeed get 5x, which is what we want. So that's the pair we were looking for, numbers 2 and 1. Once we find the numbers, we can straightly write the factorized form. Keep in mind that to do that, we write what we see. In our case, the factorized form will be 2x plus 2 times x plus 1. Second example. Factorize 4x squared minus 8x minus 5. Again, we will start by finding the values of s and p. Here p is negative 5 and s is negative 8. So we would construct again a table. We would put negative 5 on the top right corner, minus 8 alongside with an x So we would write minus 8x above the vertical line, and we would need to write 4x squared as a product of two terms that both contain x. So one way of doing that would be to write it as 4x and x. Next, on the right column, we would write all the pairs of numbers that satisfy the product condition. In other words, we should write all those numbers that, if multiplied, they give us number -5. These pairs are 1 and -5, -1 and 5, 5 and -1, and -5 and 1. But look here that although each pair of numbers satisfies the product condition, they all give us a product of -5, none of it satisfies the sum condition. So what do we do here? Will we call it a prime and admit that it cannot be factorized by the table method? Well, although the table method works only for cases where the numbers we search for are whole numbers, in other words, integers, before we quit, we should give it another try. And that's because maybe the problem was in the way we wrote 4x squared as a product of two terms. Maybe instead of writing 4x squared as 4x times x, we should have written it as 2x times 2x. So we construct a new table from the beginning. We once again put -5 on the top right corner, minus 8x above the vertical line, all the combinations of pairs that can actually give us a product of -5 on the right column, but on the left column now, instead of writing 4x and x, we write 2x and 2x. And if you do the checking, you will see that this time we managed to find a pair of numbers that satisfied both the conditions of product and sum. And these numbers are -5 and 1. Indeed, let's do the checking part together. 2x times -5 is equal to minus 10x. Then 2x times 1 equals 2x. So if we add -10x and 2x, we would get -8x, which is what we wanted. So the numbers we were looking for from the beginning are numbers -5 and 1. Thus, the initial expression 4x squared minus 8x minus 5 can be written in form 2x minus 5 times 2x plus 1. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways. As always, thank you for your time.